Welcome to the C2 Pipeline Innovation and Curiosity Center Drug Toxicology and Detection Lab. After this lab, you should be able to understand terminology regarding drug toxicology, understand the job of a forensic toxicologist, understand how drugs can enter the body, understand how drugs are collected, and determine a match for a powder. The word toxicology is formed from the Greek words toxikos and logos. Toxicology is the study of symptoms, mechanisms, treatments, and detection of poisoning. Forensic toxicology centers on the determination of toxic substances in human tissues, organs, and bodily fluids such as urine and blood, and the subsequent determination of the role that any toxic agents may have contributed to or caused death. Toxin is any material that is considered to have a life-threatening effect on a living organism. Poison is a subgroup of toxins. They come in many forms. They can be gaseous, liquid, solid, from animals such as a dog bite, minerals, and even vegetables. Poison enters the body in one of four ways. It can be ingested or eaten, inhaled or breathed in, absorbed into the skin, such as a lotion or a cleaning product, or injected. This is usually done with a needle. Forensic toxicologists provide answers to questions that may be asked during a legal investigation or at a subsequent legal hearing. These are the questions that they answer. Was poison involved in the case? If so, what was the nature of the poison? How was the poison administered? And was it at a potentially lethal concentration? Forensic toxicologists investigate the following: accidental poisoning, drug abuse and/or overdose, suicidal and/or homicidal poisoning. 75% of the evidence evaluated in the crime lab is drug-related. The most reported toxins or poisons are the following: household cleaning supplies, analgesics such as aspirin or acetaminophen, cough and cold remedies, sedatives, hypnotics, antipsychotics. They can be cosmetics, plant scrapes, insect bites, pesticides, topical creams and lotions, hydrocarbons such as gasoline or kerosene, antimicrobacterial soaps, food poisoning, and alcohol. Drug absorption from the GI tract or gastrointestinal tract is dependent on the rate and amount of intact drug and the rate it reaches circulation after oral administration. Rate is affected by the solubility, the absorption across the membranes, gastric emptying, and metabolic rate. To properly collect drug evidence, generally common sense is the best guide, keeping in mind that the package must prevent the loss of contents and/or cross-contamination. Cross-contamination would be if one substance touched another substance, then both substances are now contaminated or ruined. Often, the original container in which the drug was seized will suffice. All packages must be marked with information that is sufficient to ensure identification by the officer in the future and establish the chain of custody. In any criminal investigation, the goal of the investigators is to determine the most likely scenario. The evidence offered by a forensic toxicologist may offer only a small part of the larger picture. For example, was the toxin ingested accidentally or was it ingested on purpose? If it was ingested on purpose, was it ingested with the victim's knowledge or without their knowledge? To answer these questions, the evidence gathered by the forensic toxicologist is examined in context with all other available evidence at the scene, such as fingerprints, footprints, hairs and/or fibers, and any other trace evidence to help determine the most likely cause, and in some cases, the most likely suspect. Let us now begin our lab investigation.